Hello. So this is the video explanation of how to interface an ultrasonic sensor with an Arduino using TinkerCAD. So over here you can see the circuit diagram. This is the Arduino Uno R3 and this is the ultrasonic distance sensor which can be available in the list of components over here. Now an Arduino is interfaced with this ultrasonic sensor. So an ultrasonic sensor is a proximity sensor that detects any object or an obstacle in its path and it calculates the distance. An ultrasonic sensor has two circular structures as you can see. This over here T is written, that's the transmitter, and this one is the receiver. The job of the transmitter is to transmit the ultrasonic sound signal. When it's transmitted, it hits an object and it's reflected back to the receiver. An ultrasonic sensor has 4 pins: VCC, trig, echo, and ground. The VCC pin is connected to the 5 volts of the Arduino. It can be shown from this red wire. The trig is connected to the pin number 10 of the Arduino. Trig is the trigger pin. It acts as the output and it's the transmitter. It transmits the ultrasonic sound signal. Now the echo pin. The echo pin is connected to pin number 9 of the Arduino using this yellow wire. The echo pin acts as the input and it's the receiver. It receives the reflected signal. The 4th pin is the ground. It's connected to the ground of the Arduino. Now let's look at the code explanation. So this is the code. Over here, first we declare the variables in the pin. So the trigger pin is connected to pin number 10. So this variable is pin number 10. So we declare it here. The echo pin is connected to pin number 9 of the Arduino as shown in the circuit diagram. So how an ultrasonic sensor works is it calculates the time taken for the signal after the signal is emitted from the transmitter to the time where it comes back to the receiver. So using this time, we calculate the distance. So we have to declare two variables, time and distance. In this code, we use two loops, void setup and void loop. The void setup loop repeats only once, while the void loop repeats continuously throughout the code. Now, in the void setup loop, you can see first we initialize the trigger pin as the output, and then we put the echo pin as the input. Serial.begin 9600 basically begins the communication. Void loop. So over here, first we set the trigger pin as low because it needs to be cleared in case it's high. We give it a delay of 2 microseconds and then we set it as high. When it's high, it transmits the ultrasonic signal. A delay of 10 microseconds is given before another ultrasonic signal can be transmitted. Then it's set as low again to stop the transmission. Now we calculate the distance. So when it's set as low, this whole thing keeps repeating again and again. So then we calculate the distance. So first, the time is calculated by using this line over here. So then we have the flight time. This is the time taken for the ultrasonic sound wave to be reflected from the object and come back to the receiver. Then we calculate the distance. So the formula for distance is equal to speed into time. So we multiply time by 0.034 divided by 2. 0.034 is the speed of sound in air. And we divide it by 2 because the flight time is the total time taken for the ultrasonic sound wave to go to the receiver and then come back. So this is more than the distance. This is double distance. We only need to calculate the distance of the ultrasonic sensor and the object. So to calculate the distance between them, we have to divide by 2. And finally, we print the distance. Now, as you can see here, we'll stimulate the code. So the output can be seen on the serial monitor here. So over here, you can see the distance is this. It's displayed on the serial monitor. This is the object. As you move the object, the distance changes. As you can see over here, if I bring it closer, the distance decreases. As it goes further away, the distance increases. Okay, so thank you. This is the explanation for how to interface an ultrasonic sensor with an Arduino.